Hello all, good evening.
Good evening, ma'am.
Good evening,
Yeah,
ma'am.
good evening. So today we are going to do week 7, right?
Yes, ma'am.
Yes, ma'am.
How many of you have watched the lectures?
Not fully, ma'am.
Not fully. How many lectures did you watch?
One.
Only one.
Ma'am, seventh week I have almost except last lecture I have completed.
Hmm. That's good.
I'm just having one specific doubt in the last second lecture. That is, it's saying that neither A nor B. So
Hmm.
neither A or B. Does it means the union thing or just the individual thing? So that was a confusing point for me.
Okay. Let me, can you direct me to the lecture? I mean, where is it?
Sure, ma'am. Just give
Maybe
me.
it's, if this is for some specific example, I can tell you.
Ma'am, I have shared it in the chat, the screenshot of the scene.
Okay, now wait, hold on.
Previously, what I
Where
understood.
is it? Okay. Here
pre-
I don't see it. You can go ahead. Tell me.
Yeah, previously what I understood from the either statistics or mathematics was
Hmm.
that it's going to be only statistics only or only mathematics, but not
No,
both.
no, no. No, it's not like that. Um, like either A or B, right? So this is A union B.
Okay,
So
okay, ma'am.
mm,
But I thought that only when it's mentioned that A or B, like stats or maths, then we have to consider this uh, individual cases. So I differentiated both the cases.
no, no, no. It's the same thing. Either statistics or mathematics means probability of A or B, A union B. basically.
Okay, ma'am.
Hmm?
Thanks.
Yeah. Okay. Now, before we start, does anyone else has any specific doubt if they have watched the lecture?
Ma'am, will you be discussing practice assignments, ma'am?
Practice assignment questions?
Uh,
Uh, yeah, sure. That we can do.
can we try the second question in the practice assignment?
Okay, let me share my screen. I will write all the doubt at one place. I think this is the first session for you, right?
Yes, ma'am.
Yes, ma'am.
Okay. Uh, yes, this is open session for week 7. What are the sessions do you have? I think one you have solved with this on Tuesday. And do you have another session on this Sunday, right? I think.
Yes, ma'am.
Hmm. So I will cover both your doubts and like if you have any doubt, I mean, if you have any doubt from the lectures and if you have any doubts from the assignments from week 7. Okay. Right. Maybe on the side, I will write down the doubts that you may have. Okay, can you tell me the question number? What?
Ma'am, I will send it in the chat, ma'am.
Yeah, sure.
I have sent.
Okay.
Question 2, ma'am.
Yeah. Question number 2. Okay. Okay, I will present this screen maybe.
Question 1 also I got wrong answer, ma'am. I tried
Okay.
question number 2 is looking more complicated.
This is lecture 7.5. Is it 7.5? Why? This is practice assignment 7.1. Okay.
Yes, ma'am. It's not graded.
Okay. Oh, not this yet. Yeah, this one. I think I have some different set of questions over here.
And that's why I shared the screen. Because every
I
time
think if I refresh, I think I should get different set of questions. Yeah, I think one.
question 3.
Yeah. Yeah, okay. So question 3 says if E1, E2, E3 up to En are non-empty disjoint sets and subsets of sample space S, and the set En plus 1 is also a subset of S, then which of the following statements are true? Okay. I think we'll have to work out this question. So, okay. Here, the first option, it says E1 intersection En plus 1, like intersection of each of these En with En plus 1 is disjoint. So, first of all, what do you understand by disjoint events?
It means whatever we get in one event, those outcomes will not be there in the other event.
Right.
For example, event for getting odd number is disjoint from event of getting even number when rolling a dice.
Correct. So, the first option we have like well, I think I should draw something. Okay, let's first see if we are able to do it just like that. Otherwise, I will maybe draw. So, first of all, you are given that all these EIs are disjoint, right? So their intersection, if you take the intersection of all these events, that should give you 5. Now, each of these events, so let's say, if we look at option A, E1 intersection with En plus 1 and E2 intersection with En plus 1, so on till En intersection with En plus 1. We have to check whether they are disjoint or not. So to check whether they are disjoint, we need to know that the intersection of all these events. So now our event is not E1 or E2 or E3 like that. Now our events are, the first event is E1 intersection with En plus 1. The second event is E2 intersection with En plus 1. The third event is E3 intersection with En plus 1 and so on. Right? So just like that, we have n such events. Now, if you look at E1 intersection with En plus 1, so each of them, like this event altogether, this will be contained in E1. Is it like, are you able to imagine this? Like if you can draw the Venn diagram, let's take one event as E1, one event as En plus 1. If you take their intersection, that will be contained in the event E1. Is that all right?
Yes, ma'am.
Similarly, if you take the event E2 and you take the intersection with En plus 1, that, so their intersection will be contained in the event E2.
Yes, ma'am.
So on, you can go on like that. So what you will get is, maybe I think drawing figure is better. Oh, hold on, I will share the another screen. This is practice assignment. Some question, maybe everyone will get different set. So we have what is given to us is all these E1, E2 up to En are disjoint, right? Now saying that all these events are disjoint, we have that intersection of EIs E1 intersection with E2. I will revise the topics also. I know many of you would not have seen the whole lectures, so it's fine. After this question, we'll We'll go through all the topics. So what we're saying is there should be 5. Now there is another event which is en plus 1, which we are saying is also a subset of your sample space S, right? Then option A, which is you have to check whether E1 intersection with En plus 1, this is one event. Then E2 intersection with En plus 1, this is another event. So on till En intersection with En plus 1, right? So all are another event. I mean, these are now are n events. Now, as you can see, since E1, E2, E3, E4, let's say such that we have some n events. So let's say this is my E1, this is my E2, this is my E3, this is my E4, and this is some En. Okay. And since they all are disjoint, I have made it separately. Now, if I take the intersection of all these events with En plus 1, I mean, it's difficult to draw these figures. I don't know how to actually draw this, but okay. Maybe you could have done something, but all right. So what we're saying is you have to take intersection of all these events with En plus 1. So here I'm drawing it separately, but actually En plus 1 is the same, just one set, one event. And your all the sets should have been arranged in a way such that you could have taken the intersection of En plus 1 with each of these events. So, but this image, I mean, what I have drawn here is going to be not true. Okay, just for example, I'm just giving you, just to understand, I'm just drawing it here. So let's say this is my En plus 1, okay? Or if I can try, let's say this one. Okay, let's say this is my En plus 1. Let's say this with just 2 events, E1 and E2. And now we are looking at their intersection with En plus 1. So if we take their intersection, so intersection of En plus 1 with E1. So this is this one. If we look at intersection of En plus 1 with E2, this is this one, right? So this is E1 intersection with En plus 1. This is E2 intersection with En plus 1, right? Now, you can see that this event now, E1 intersection with En, so E1 intersection with En plus 1 will be contained in as a subset of E1, right? Similarly, this E2 intersection with En plus 1 will be contained in E2. I mean, you can also call it subset. I'm saying just contained in. This is basically subset notation. So E2 intersection with En plus 1 would be contained in E2, and so on. You can go on further, and you will get even this event En intersection with En plus 1 will be contained in E1. And now, since all of these events like E1, E2, E3, A4 till En, they all were disjoint. So you could think like that even all these events that we have taken over here, this set of event, they will also be disjoint, right?
Yes, ma'am.
So like looking at just these E1 and E2, you are able to imagine that, right?
Yes.
Yeah, now you extend this further to En, and that should that should give
Okay.
you.
Okay.
Now, if we look at option B, we can represent it through horizontal lines. Yeah, that is, yes, exactly. That can also be done.
I understood.
But
Ma'am, that family of 12 people sitting around in the round table where couple A wants to sit together, I've
okay.
written 0.91 as the answer for probability.
Couple, where is it? Family, in a family
Previous
gathering.
question. Family
In a
gathering.
family gathering. Okay.
12
In a
people sitting
family.
around. So we
Okay.
have to take 11 factorial, no, ma'am, for a circular arrangement.
12 people sit around a table. Among them, couple A wants to sits together. What is the probability that couple A sit according to their wish?
So here, what I did was I took
Mhm.
for 12 people,
See,
there are 11 factorial ways of arranging.
yeah, why? Okay.
And I took couple as one entity, so there were like only 11 people
11.
like that. Then I took
Mhm.
10 factorial as the answer. So I divided 10 factorial by total 11 factorial. Is it something wrong that I did, ma'am?
10 factorial by 11 factorial.
Ah,
But you missed the point that now since you're considering the couple, so even the couple you can arrange in two ways,
two
right?
factorials. Okay.
So that you have to bring
So
into
if,
consideration.
so if it is okay, if it is 2 by 11, then also the answer is not,
Then also the answer is not right.
no, it'll be, sorry.
In a family gathering, 12 people sit around a round table. Among them, couple A wants to sit together. What is the probability that couple A sit according to their wish?
Okay, ma'am, the answer is correct. If I take the 2
It's correct?
factorial, then the answer is correct, ma'am. Thank you.
Okay. All right. So I'll just quickly go through all the topics that has been covered. If there is something you're not able to understand, you can stop me in between and you can ask your doubt. So week 7, we are going to look at these topics, these major topics. So you have random experiment, outcomes, sample space, events, probability, Venn diagrams, and union and intersection of events. Okay. So
Excuse me, ma'am.
yeah,
Actually, I've joined just now. Are these topics are like any of these topics have been discussed right now? I'm just asking, ma'am.
no, not yet.
We are going to. Okay. Okay. Thank you.
All right. Okay. So first, let's start with random experiment. So before we go to random experiment, like you would have always heard about the term experiment, right? In your courses, somewhere in the class, you will you will perform some experiment, right? But what is random here? So a random experiment is something where you don't know for sure, like what outcomes are you going to get. Okay. Like a very simple example that we generally start with, like tossing a coin. So when you toss a fair coin, let's say now in this case, your experiment is tossing a coin. All right, tossing a coin, let's say 10 times, and uh, checking whether a coin is fair or not. Maybe something like that. Now, when you toss a coin, and this is a random experiment, this is your experiment, you know that you have two outcomes. You're going to get two outcomes, either head or tail, right? But you don't know like whether you are going to get head or you're going to get tail. So there is some randomness. I mean, you can't say for sure that okay, when this is the outcome that you're going to get, right? So such kind of experiments are termed as random experiment. Like the another example you can take, again, it's a very basic and example that has been taken very often. So rolling a fair die or rolling a die, right? So again, you don't know what the outcome you are going to get. It can be either 1, it can be either 2, it can be either 3, and so on, right? So the outcome of the experiment, whenever you don't know, like what the outcome you are going to get, then such kind of experiments that you perform, you call it as random experiment. Now, the next thing is you have sample space. So this is done. So sample space is collection of all the outcomes of a random experiment, right? So here, maybe you would have seen the notation of sample space as a capital S in the lecture. So when you perform an experiment, when we perform a random experiment, all the outcomes that you can get for this random experiment, that you will call it as sample space. For example, like when we said the experiment is rolling a fair die. Okay. So what will be the sample space here? What will be the sample space?
All the
1, 2, 3, 4, 5, 6.
Set of all the outcomes.
1, 6. 1 to 6.
Mhm. So this is what you call it, sample space. So whatever possible outcomes whatever outcomes are possible, collection of all those outcomes, when you write it in set form, that is a sample space. Now, from the sample space, now we have events. So event is nothing but a subset of sample space. So events is a subset of sample space. That's this. So let's say we ask, let's say we are interested in define an event which takes define an event where the outcome is a even number. So let's say I denote this as event E1. So this event would be, since we're interested in an even number, I will write it here.
2, 4, 6.
You will have 2, 4, 6, right? If we define an event such that the number you obtain, the number you get after rolling a die is greater than 5. Okay. So greater than 5. So what is this event? It's going to be
6, ma'am.
6.
6.
So this is how you're going to define the events. So event is nothing but subset of sample space. So given any random experiment, you should be able to write, the first thing that you should think, like what are the outcomes, okay? And whatever outcomes is possible, you write the sample space, all right? So once you have the sample space, you will get some questions on probability. So after this, we're going to deal with probabilities. So in maybe a question will ask you to find the probability of getting an even number, or find the probability of getting an odd number, or find the probability that the number is greater than 2 or 4, or it lies between certain range. So you'll get things like that. So looking at those, you should be able to write, you should be able to define your event accordingly, right? So that is one skill that you should learn here, like how to identify from the question, how to identify the events, like how do you define the events. It's important. Now after events, there are certain questions. Okay. Then okay. In events, we'll also look at union and intersection of events. So suppose, for example, we had taken an event E1, all right, and this event E1 is A, comma B, comma C, and we have another event E2, which is B, comma C, comma D, all right. So when we talk about the union of two events, so that should contain the set of all the outcomes, which is in either E1 or E2, right? So, I mean, you should not leave any outcome from E1 and E2, basically. This is what you should take care of, right? So that is why we have written E1 union E2, this event. So again, this is also an event, right? See,
Yeah.
we are saying E1 and E2 are events, but this E1 union E2 is also an event. Okay, this is also an event. So E1 union E2. So first you should look at what all outcomes you have in E1. So you have A, B, and C. So I will write A, B, and C. Okay. Then I look at E2. So E2 has B, C, and D, right? So B and C I have already written in this event E1 union E2. So that I skipped. So the only thing that is left is D. So that we have written over here. And why we did not write, since it's I mean it's a kind of, it's a set, right? So you don't repeat values or entities in a set, right? So E1 union E2 is just A, comma B, comma C, comma D, because it contains all the entries that are there in E1 and E2, E1 or E2, right? So E1 union E2 is also called as E1 or E2. Okay. Now, next is E1 intersection E2. So E1 intersection E2 is also an event. This is also an event. And here you should look at the outcomes which is present in both E1 and E2, right? So if I look at entry A or outcome A, it is there in E1, but it is not there in E2. So it will not come in our event E1 intersection E2. And you can see that we don't have A here. But outcome B and C, as you can see, it is present in both E1 and E2, right? So that is coming in our E1 intersection E2. And E1 intersection E2 is also, you can also write it as E1 and E2. Okay. So this is E1 union E2. And this is E1 intersection E2. All right.
Yes, ma'am.
I think maybe you can just work on this. All right. So here what we have taken is, now our experiment is tossing a fair coin 2 times. Okay. So our experiment is tossing a fair coin 2 times. All right. So when you're tossing a fair coin 2 times, what is the sample space?
H, comma T, head or tail.
H, comma T?
H,
Four.
HT.
H, T, TH, and TT.
HH, HT, TH, and TT. Now, okay. We have defined an event E1 which says head on the first toss. So what will you write even as?
HH, HT, and TH. Sorry, HH and HT.
Yes. Head on the first toss. So HH, HT. And what will you define E2 as?
TT.
TT, right? So you are able to write, like, given a random experiment, if you are asked to write an event, you should be able to write it. Now, there is something called null event, right? So null event is like when you have outcome to be 0. I see something on chat. Okay. Someone has asked what is the meaning of fair coin. So fair coin is not something which has both head and tail. Or an unfair coin is not something that has only head and not no tails, or and vice versa. It's not like that. Fair coin is something where the probability of occurrence of head and tail are equal. I mean, you should not get like something like when you toss a coin, it shouldn't be like head is occurring more frequently than tail, or more often than tail. In that case, your will say like this is unbiased, not unbiased, or it is unfair. I mean, it is not a fair coin, because suppose I toss the coin 100 times or 1000 times, and I'm getting some 900 times head, which doesn't, which is like kind of unfair, right? I mean, the probability that head occurs or the probability of tail occurs, it's not same. So such kind of in such a case, in such a whenever you come across um certain coins, you will say it is unfair. But in general, yeah, same thing, like what is a fair die? I mean, when the chances of like the chances of occurrence of the numbers from 1 to 6 are same. And these are not given in just like we toss a coin 10 times and we decide. It's not like that. Like the number of times you repeat the experiment should be sufficiently large. Like it should be sufficiently large to come to a conclusion. So
Ma'am, can you explain once again these cases, fair and unfair?
yeah, fair means like let's say if I'm saying fair coin. So in a coin, there are two sides, right? One is head, other is tail. So when head and tail both has the occurrence of head and tail are the probability of occurrence of head and tail are same. In that case, we call such coin to be fair. And if it is not, then we call it unfair.
Okay,
Because
ma'am.
because coin has two sides, right? So if I'm going to say same, it means a probability with which head should come should be 0.5, and probability with which tail should come should be 0.5.
But there's also a possibility that, like, if a coin is tossed 1,000 times, there's also a possibility that we can get 990 heads. Like there's a possibility, but it is very low. So in that case, what is the thing? Like you said that it's unfair for tails.
Sorry, can you repeat your question?
Ma'am, I mean, like if we toss a coin 1,000 times and if we get 990 heads times head,
Hmm.
ma'am, actually we are the chances of this event being like actually happening is actually very low, but it is like we are rolling a fair coin. So in that case,
No,
what should be?
we are not saying we're rolling a fair coin. I mean, we are not we are not saying anything. Okay, we are repeating the experiment to check that.
So, ma'am, can we assume like if uh, like if we are having like every element is having in an like let's say like if we are rolling a dice and every element of dice is having equal percent of occurrence. I mean, they have equal chance to have their
Hmm.
occurrence. So that thing can be a fair thing, fair
Yeah,
dice or fair.
that would be called as fair dice. So like checking whether, I mean, all this kind of checking the fairness of a die or checking the fairness of a coin, you will study like in detail in stats 2 courses when you come across this goodness of fit test or hypothesis testing, all that. So you'll get to see that okay, this is all this sort of things we can do to check the fairness of a coin or like very simple things, right? So you will study how all this test or inferential statistics work there. So let's keep this aside for now. If for now you just need to know, okay, when you're talking about a fair coin, it means probability of head equal to probability of tail, which is 0.5. Now, when we are talking about fairness of a die, probability of 1 equal 2 equal 3, go till probability of 6 should be 1 by 6. Okay, that's all you should know for now. All right. Now, coming to the null event, you have, I mean, null event is, I mean, when there is, basically there is no outcome, right? When your outcome is 5. For example, in this case, we have taken, let's say, E1 as head. One event is defined as head and other event is defined as tail. Now, if I want to define E1 intersection E2, this is 5, right? Because there is nothing, there is no outcome that is common in both E1 and E2, right? So such kind of event where the outcome is 5, you call it as a null event. Okay, so we'll say H1 intersection H2 is a null event. Now, on the same line, like when you get things like the intersection of 2 event is 5. So these, I mean, these 2 event separately, they will be called as disjoint or mutually exclusive events, right? This is what we were discussing in the question from the practice assignment. Like when what is meant by disjoint event. So disjoint event is like if you have 2 events, E1 and E2, or event A and B, such that their intersection is 5, then such events so are called either mutually exclusive or disjoint event. Okay. Then complement of an event. What is complement of an event? So suppose in your sample space you have here we have example for
Can you repeat the
coins.
disjoint even?
Hmm?
Can you repeat the disjoint even?
Disjoint event. So disjoint event is like let's say you have an event E1. Okay, and you have another event E2, and you find, if you see that intersection of E1 union E2 is 5. So if E1 intersection E2 is 5, then E1 and E2 are disjoint events, or you can also call it as mutually exclusive events.
But ma'am, what is the difference between null event and disjoint
Hmm.
event? The more
So yeah,
same.
no. So when see disjoint events, we are saying, right? We are saying E1 and E2 are disjoint events, right? Or E1 and E2 are mutually exclusive events. So what we're saying is if the intersection of 2 event is 5, then we call E1 and E2 are disjoint events or mutually exclusive events. But if I look at the event E1 intersection E2, if I look at the event E1 intersection E2, and if this is phi, and here I've just taken an example, right? Yeah, basically what we are saying is, if you have some event F which is phi, then this event F is called a null event. Okay.
Oh, I can't understand.
Hmm. You're not able to understand?
Yes, ma'am.
Okay. For example, let's say you
Okay.
have,
Ma'am, can I tell?
okay. You can go on.
If
Go
it
ahead.
is a die, if you're rolling a die, there
I
is a
will write
probability
that.
of getting even number or odd number, right? But what is the probability of getting both even number and odd number? No, nothing. That's a null event. That's nothing. It cannot happen. It is like that.
Yes.
Okay. Yeah.
So basically, the example she gave. So you can write this as even as getting an even number, right? Getting an even number. E2 as getting an odd number. Okay. And now you define E1 intersection E2. So this is also an event, right? E1 intersection E2 is an event,
Yes, ma'am.
right? Which is phi. So you will call this event E1 intersection E2 as null event. But you will call E1 and E2 as disjoint events. Or E1 and E2 are
Separate events are is called disjoint. The
separately.
intersection of two events is called an null event. That's right, ma'am.
Yes. I mean, for this
Okay.
example, I mean, this is in terms of this example.
Okay, ma'am.
I mean,
understand.
separately, you will call it as disjoint events.
Okay, ma'am.
Okay. Now, complement of event. So, if we take the same example, so E1 is getting an even number. So, complement of E1, this is how we denote it, like a small c we write on the top. So, E1 complement will be getting an odd number, right? Complement is everything. So, basically, this is S minus E1, right? So S minus E1 is, since in E1 we had 2, 4 and 6, and if we subtract 2, 4 and 6 from S, you will get 1, 3 and 5. Right?
Yes, ma'am.
So this is what we understand by complement of an event. For example, here, if we have taken S to be HH, TT, TH and HT, and we had taken an event E as H, H, HH, then E complement would be everything in S but E, right? So we remove E from S and you get HT, TH and TT. And since S is a sample space, if you take the complement of a sample space, this is phi, which is a null event, right? This is phi.
Yes, ma'am.
Ma'am, can you
Excuse me,
give
ma'am.
example?
Ma'am, here we can say also that this event E and E complement are also disjoint.
Event E and E, yes, exactly. So we can call E and E complement are disjoint events.
Yeah, okay.
Yeah, someone else had doubt, no?
Ma'am, can you give another example?
Another example, okay. I think we gave one example over here also.
Ma'am, for complement.
Complement only. Okay. Okay, let's say,
Can I?
yeah, you can.
Suppose like if we are like we have a dice, okay. So like that dice have a sample space of from 1 to 6, 1, 2, 3, 4, 5, and 6. So suppose like we have even event where we are getting 0, 1, 2, and 3. Okay. So like even is 1, 2, and 3. So even complement would be the events that are not inside even. So even complement would be 4, 5, and 6. So that's the complement, I guess.
Yes. Did you understand?
Yes, ma'am.
So event even was defined as 1, 2, 3, right? Now you take the whole sample space, and from this sample space, you subtract this even. Okay, and that would be E complement. So if you want to look through the Venn diagram, let's Venn diagram. Let's say this is my sample spaces. Okay. Now we can define an event over here. This is my event. Okay. Or let's say this is E1. Now, if I want to take even complement, so this whole thing that is not in E1, right? So I will leave this circle, and this whole shaded area would be E1 complement. Okay. This is fine, no? Okay. Then next we have subsets. So subsets is nothing. I mean, subsets you would have studied in maths also, and we also call that events are nothing but subset of sample space, right? So we have let's say this sample space 1, 2, 3, 4, 5, 4 to 6, right? And we have all this S1, S2, and S3. So you can see that this S1 is a subset of S2, right? S2 is also a subset of S3, right?
Yes, ma'am.
So what it means is like, if I'm writing S1 is a subset of S, it means that, this means that all the elements of S1 should be in S. Okay, this is what it means. Yeah, I mean here, if you have two events E1 and E2, and we are saying E1 is contained in E2, it means all the outcomes of E1 should also be in E2. That's all. That's all subset means. Then we have Venn diagrams. So in Venn diagrams, what we do is, like the rectangle that you see, we generally denote this rectangle as a sample space, and all the events that we define on the sample space of that we call it as that we denote it as denoted using circles inside the rectangle. Okay, this is what the representation is in Venn diagram. So here. So all this in this rectangle would represent the sample space, and all this will be event. So this is E1, this is E2. Okay, there are two samples, two events we have taken. Now, if we talk about E1 union E2, right? So, so we had the sample space, we had two events, E1 and E2. This whole thing, you should take basically everything that is uh, everything that is in E1 or E2. Okay, and so that would be this blue shaded region. And when we talk about intersection, so you look at this common area that is both in E1 and E2, right? So this common thing, common area, common region is what is E1 intersection E2. Okay. So when you have to define these events, E1 union E2 or E1 intersection E2 or E1 complement or anything that you want, you can represent it using Venn diagram. It's much easier to understand, so it's simple. All right. That was all about Venn diagrams. Any doubts so far?
No, ma'am, all good.
Okay.
Ma'am,
Mhm.
if two events E1 and E2 are disjoint and
Mhm.
subsets of S, can we say union of both will be S?
Can you repeat? If?
Suppose there are two events
Okay.
E1 and E2,
Okay.
and E1 and E2 are subsets of S.
E1 and E2 are subsets of S. Okay. Then?
And E1 intersection E2 is null set.
Okay.
Then does that imply E1 union E2 is S?
That will depend.
Hmm.
What
Depend.
is S? What is S here?
S sample space.
Okay, S is sample space. Now, are these the only events that can be defined on sample space? That is one question that we can ask.
Mhm.
Are these E1 and E2 the only events defined on S? Right, this can be asked, right? If not, let's say,
Okay, suppose let's say E1 complement is equal to E2. Then
okay,
we can say that.
E1 complement equal E2.
Hmm.
Again, I can give
Then
you one
it's
example.
possible.
Let's say I will draw a Venn diagram, right? Let's say this is my sample space. I am saying, if you, okay, let's say there are only two events, E1, E2, okay? And here I'm assuming only two events. There are only two events, E1, E2. So if this is my E1 and you're calling everything apart from E1 as E2, then yes, E1 union E2 would be S. And even here, if I'm assuming that E1 and E2 are the only events, then in that case, yeah, that is a little.
What is the question here, ma'am?
No, his question was this. He is defining two events, E1, E2 on the samples, E1, E2, he is defining two events, and such that E1, and these are events, so of course, it should be a subset of S, this is obvious. So what he is saying is, if E1 intersection E2 is phi, then can we say this?
Yes, ma'am. We can say, because if even is in even intersection E2 is 5, then it means that these two are disjoint events.
Mm.
And when we take the union of disjoint events, it gives us the sample space. Yes, ma'am.
But then no, we cannot say, I mean, because only these two sets are given as disjoint, but we don't know about the rest of it, right?
Yeah, that is why I have defined even complement as E2.
Yeah, that
So
is why he gave.
Then it is correct.
Yeah,
Okay,
then it is correct. That's what. So E2 is everything apart from E1. Then yes.
Ma'am, then
okay,
whole
that
like the
means
union would be whole set. Like
Then
that's
in
pretty
that
much
case,
not
E1
everything.
what?
Like if we have a complete set, okay, like if we have a range and E1 is complement of E2. So what E1 has uh,
Hmm.
like that will not be with E2.
Hmm.
So basically if we like combine it, it's a whole set.
Yeah, that is true. I mean, with this example, I am fine. I mean, giving that even complement is E2. Yes, even union
Yes,
E2
ma'am.
is
That
S.
particular thing has to be given. Yeah.
Yeah.
Yes, ma'am.
But like there's one thing that crossed my mind just now. If we have a set if we have a range from 0 to infinity, and even the subset of E1 is 1 to 1 comma 2, and subset of E2 is uh okay, it would be like if E2 is equal to E1 complement, then its subset would be from 2 to infinity. Nah.
No. Tell me
Okay,
again.
ma'am.
What is your you got you got the dot.
Yeah, I think I just
Hmm.
got that.
Okay, fine. Then I think we can go
Ma'am,
ahead.
I have one doubt.
Tell me.
Ma'am, I posted one question in the chat box. I was able to see clearly.
Hmm. Okay. The question is, suppose we record the total number of coin tosses in tossing a coin until we see 2 consecutive tails. Then the sample space is total number of coin tosses. Okay. See, from here, the first thing that you should identify is what is your random experiment? What is your experiment? Can you tell me?
To find out the consecutive results.
No, your random experiment is you will toss the coin until you get 2 consecutive tails. Okay. So how many times would you toss how many times you should toss the coin?
More than
Minimum you should toss the coin 2 times,
yes, ma'am.
right? So, either you will toss the coin 2 times or 3 times or 4 times and so on, right? Because
Yes,
just if you start from 1, I mean, starting from 1 would be, I mean, if it is just 1, then in that case, you won't be able to figure out whether you are getting 2 consecutive tails or not. You need to have at least minimum of at least or minimum of 2 tosses.
answers.
Yeah.
Ma'am,
Okay.
can you explain once more? I'm not clear about the idea.
Okay. What does this says is your question is, so in this question, random experiment is tossing a coin until you get 2 consecutive heads or tails, something, right? So, to perform this experiment, how many times do you think you should toss the coin?
At
You
least
get
2 times.
two
Times.
times. You
So
have
it
to
can be
toss.
2, it can be 3, it can be 4, it can be 5, so on. So actually here the question, I think it shouldn't be like this. Maybe, okay. So tossing a coin until you get 2 consecutive heads. So if you are tossing a coin 2 times, you will have then only you will see head, head, tail, 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 head, or head, tail, right? If you toss the coin 3 times, then you will have all these outcomes, right? Head, 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 tail, and so on. So to get 2 consecutive tails or 2 consecutive heads, you need to throw your coin at least 2 times. So that is why we are starting from 2, 3, 4. I mean 2. Okay. All right. We move to probability. So I think I think probability we are starting now only.
Ma'am, for the question that you just discussed, it's saying that 2 consecutive head. So in that case, the even space for us will be that we first do 2 consecutive tosses, then 3 consecutive tosses, then 4 consecutive tosses, and so on. Based on that, this is going to be our event space for this question, no?
For this question.
Yeah, for checking that 2 consecutive head.
You are saying event, you are defining your event now.
The last question that you were just discussing now, that you should in how many tosses are we going to get our 2 consecutive heads?
Yeah.
So in that case, like it's at least it's going to be two tosses. So first event space is going to be even is going to be the pairing of two, that is head tails, tail heads, and head tails and tail heads. Then it might happen that in this 2 tosses I might not get head. So I might have to go for 3 tosses. In that I will have 3 pairings. Similarly for D3, I will have like 4 tosses and so on. This is going to be the even space now for me in this case.
Yeah, those will be event spaces. Okay. This was the last topic. Yeah. Okay. All right. What do you understand by probability? Can anyone tell me? Like when you hear the term probability, like what do you think of it? I mean,
Probability of an
Chances to get something. Chances of
the
the
chance
element.
to get something, right? What is the chance that this is going to happen? What is the
Yes.
what is the chance that it is going to rain tomorrow? What is the chance that the answer you got is for a question is wrong?
Correct.
So all that, I mean, what is the chance basically? So that is exactly what the probability is. So we are just giving a number to it, right? So let's say here we have taken our die example. So we have all this set of the sample space, and we have defined an event E, and this event E is 1, 2, 3. So we are saying what is the probability that E has occurred? Okay, I mean, we have observed 1, 2, 3. Okay, so what is the probability? So this is nothing but number of outcomes that your E will have divided by the total number of outcomes that your sample space has. Okay, that's all we are going to say. So this number will give you the probability of occurrence of this event E. Okay. Similarly, you can define many other events, or you can come up with many different random experiment and set up the sample space and define some events on it, and you can work out for what is the probability of event. Then the second thing is the second thing we also talk about is relative frequency. So proportion of times event occurs in a long time. Like when we were talking about tossing a coin 1,000 times. So we are tossing, let's say, the coin 1,000 times, and from there we are trying to find out what is the probability of head. So probability of head will be will just be how many times head has occurred and divided by total number of times we are tossing the coin, right? So this is the relative frequency approach, like proportion of time event has occurred. So in our case, how many times head has occurred in a long time, like we are talking about, like when you perform the experiment many times. So that also gives us kind of frequency, not frequency, probability.
Can you
So
repeat?
like when you perform, what we're saying is the relative frequency approach to the probability. So proportion of times an event occurs in a long time. So the example we gave is proportion of times head occurred in a large throw of coin, in a large toss of coin, something. So that will give us also the probability. That will give us probability of head.
Ma'am, I didn't got your point. Ma'am, like just what is a relative frequency? Can you like explain it through a concrete example?
Okay. You have seen relative frequency in week 2, right?
Yeah.
Yes, ma'am.
So
Yes.
let's say you have some categories or something let's say categories. You have frequency, you have relative frequency. Now let's say category A, category B. So in our case, let's say I'm writing category A as head, category B as tail. Let's say category A occurred some 510 times. Category B occurred some 490 times. So what is the relative frequency of H? It is 510 divided by 1000. And probability of tail would be 490 times divided by 1000. Right?
No.
This is the relative frequency.
Yes,
So this is what? This is 0.51. This is what? 0.49. Okay. So this relative frequency that you got, 0.51, 0.49, this is nothing but probability. This is what we're trying to say. I think you won't
Understood, ma'am.
Hmm.
Just like there is one point I think which is a confusion, because relative frequency, like it is written the proportion of times events occur in a long time. So in a long time, that is long time. I'm not getting what is long time here.
Yeah, in a long, okay. So in our case, we took the long time as we performed the experiment many times. That is our long time here.
Okay. Oh, okay. Like frequency is 510.
Hmm.
So we have performed the tossing of the
Tossing
coin
for
many of
1,000 once a 1,000 time.
okay.
So
Okay.
it's a long time here. Yeah.
So means
Maybe
this 1,000 thing, that is, we are performing this experiment
yes.
1,000 times.
Yeah, yes.
That's what concerns the long time.
What? Can you repeat?
This we are tossing, repeating the same event 1,000 times. That's what's giving it a time frame, na? That we are repeating the same
Yes.
same event.
Yes. So this is all what probability is. Now there are 3 axioms of probability. So whenever you so there are 3 axioms that probability follows. So one is that probability of any event should always lie between 0 and 1. So what we have, you should always, this is like very, very, you should always keep this in mind. Like probability of any event, like whenever you are asked to find the probability, please make sure, please note that this always lies between 0 to 1. Okay. You shouldn't write like whenever you are asked to find the probability. You should never write that probability is some 200 or 2 or 2.5. It is not going to happen. Okay. It should always be a number between 0 to 1. All right. And the second axiom that we have is probability of the sample space equal to 1. So, for example, you have let's say you're tossing a coin 2 times, so you have head and tail. This is my sample space, and if I have to find the probability of S, what is the probability that this event occur? So we can go with the same definition. So number of outcomes that your event has. So in this case, our event has 2 outcomes. So 2 divided by total number of outcomes, that is 2. So this is just 1. So probability of sample space should always be 1. And the third is mutually exclusive events. So let's say you have a collection of events, E1, E2 up to En, which are mutually exclusive. It means their intersection is 5. Okay. So their intersection is 5. Then if you have, what we are saying is, if you have a collection of mutually exclusive events, then probability of union of EIs, I varying from 1 to infinity, is nothing but sum of the probabilities of all these events, which is probability of E1 plus probability of E2, so on till probability of En, if it goes to En. Okay.
Excuse me, ma'am. If these all like E1, E2, and all the events are mutually exclusive, and then the intersection is going to be 5, then the probability of all these events should also equal to 0, I think.
Why?
Because if they are mutually exclusive, if they are just disjoints, then the resultant value is null 5 only. Then and the probability
No.
of 5, I think, is 0.
We are not saying intersection. We are saying union of all these
Union.
events.
Okay.
Yeah.
Okay. Sorry.
So when you are
Okay.
doing union, it will add up.
Yeah. Okay. Sorry.
So from there, there also comes the addition rule of probability, which says if you have suppose 2 events, E1 and E2, then probability of E1 union E2 is probability of E1 plus probability of E2 minus probability of E1 intersection E2. So how is it happening? So let's see this. So suppose you have this sample space. Suppose you have the sample space. You have this event E1. You have this event E2. All right. Now, if I want probability of E1 union E2. So first of all, E1 union E2 is all this. Right? So here E1 and E2 need not be disjoint or mutually exclusive. So we cannot write this as probability of E1 plus probability of E2. We cannot write this as this, right? It may not be true. So what is happening is you have this E1 and then you have this E2. So if you add these two, you see that this intersection is something which is appearing 2 times, right? Once in E1 when you are marking this, when you are shading the region E1, and second when you're shading the region E2. This is coming 2 times, right? So if we subtract one of this, then it would be, in that case, this would be equal. And that's how we are getting probability of E1 union E2 equal probability of E1 plus probability of E2 minus probability of E1 intersection E2. And this is called as additional rule of probability. Okay.
Ma'am, just hypothetically speaking, understood this like rule, by watching the Venn diagram. But just hypothetically speaking, like what if we just did a union of E1 union E2? We add up the probability. We just add up the probability P even probability of E1 plus probability of E2. So like what will happen?
If we add probability of E1 and probability of E2,
will that exceed 1?
Will it exceed 1?
In that case, what we are having is some additional count. If we are not subtracting this intersection thing, then we will have some additional fraction. And it might happen that it might exist. We cannot certainly say that it might exceed 1 or will not.
Or not. Yeah, that's what. And we cannot say this for sure.
But the summation of all the events should be equal to 1, no? So
No. I mean, okay. Maybe we can try. I mean, it is not always true. I mean, what you're saying, right? It can happen, it cannot happen. So in case it happens, then again, from there you can easily see the flaw that, okay, I'm finding a probability and it is coming more than once. So somewhere I'm going wrong in saying that this is equal to this, right? If in case it happens, in case it comes as equal to 1, right? So from there we can make the observation that something is wrong in what we are saying. But does it happen all the time? That is what we need to check.
And probability of E1 union E2 will equal to probability of E1 plus probability of E2 only when these two events are mutually
Disjoint.
exclusive. Yeah.
Only if they're disjoint, you can say
Then
that
this,
they are.
yeah. But we have to put minus probability of E1 intersection E2 for a general case.
General case.
Like,
Yes.
yeah.
Okay. I
But
think
like
that.
ma'am, I have like tried one example, like probability of E1 is 0.35 and probability of E2 is 0.65. Then like adding them.
This is one.
Yeah. So these are not.
I mean here
disjoint.
it's they are exhaustive event. I mean,
Yeah,
you are
they are
saying
exhaustive.
this
Yeah.
is union is S, but we don't know whether the intersection is phi or not. So we cannot say they are disjoint also.
Yeah.
But
Yes,
we'll
yes.
say they are exhaustive events.
But we can use this general formula for this particular probability of events for E1 and E2.
I mean, in this case, it should be E1 intersection E2 should be phi, because just adding these
Yeah.
two events, you are getting one. So there is no way we can have something. I mean, no. What happened just now? Wait. This is probability of E1 we are saying, and this is probability of E2 we are saying.
E2. Yeah.
And probability of E1 plus probability of E2 is coming as 1. So it from there, yes, if this is happening, it means E1 union E2 is S, right? This is for sure. And if this is happening, it means E1 and E2 are exhaustive events.
Means
I'm like probability of E1 intersection E2 is equal to 0.15. Can you please take this?
Okay, wait. I think mine got closed. Wait. Now, what were you saying?
I'm like for just there's a one example, like for E1 it is given 0.35. Okay. And for E1 intersection E2 it is given 0.15. E1 intersection E2, probability of E1 intersection E2.
0.
Probability of E1 is 0.15.
Okay.
And then we can find like probability of E1 union E2, I think, because we can directly
this
put
E2 was given as 0.25, 0.65.
0.65.
Okay. So E1 union E2 is, yes, I mean, plus 0.65 minus 0.15. That's fine.
So for general case, we use this formula, but for the mutually exclusive events, we have to
only if
use
it's
only
given that, yeah, they are mutually exclusive, then
then
yes.
only. No, it is a special case then.
Yeah, so it is a special case.
Okay.
Ma'am, so like if we are given with just two possible probabilities, probability of E1 and probability of E2, like just by these two elements, can we find probability of E1, probability of event 1 intersection with event 2?
I mean, we can't say that, right? I mean, if you are given just E1 and E2 ka probability, how will you decide what is probability of E1 intersection E2? I mean, there is
Actually,
one
that's what
way.
I'm asking.
No, there is one. I mean, if they are independent, I don't think independence has been taught so far, but I'm just telling you. So when we are saying E1 and E2 are independent, then in that case, it is equal to probability of E1 times probability of E2. But if they are independent, if the event E1 and E2 are independent, then we can say that. We can write that.
Okay.
But will I think we are going to study this in next week, I guess. It should come.
Ma'am, probability if negative be possible?
No. See, look at the first axiom. What does it say? It always lies between 0 to 1.
Okay, ma'am. In which example you are taking? In that case, probability will coming mine negative.
Where is it coming negative? It didn't come negative.
Ma'am, in P of inter union E1 and E2. In that case, if we are calculating probability, it's becoming negative.
How 0.35 plus 0.65, which is 1, minus 0.15, which is 0.85. It is not negative, right? It's a positive number.
Okay, ma'am.
Okay. So theory-wise, we have completed. Do you have any questions? I mean, any assignment problems, something?
Ma'am, just a general question. This is everything that covers week 7.
Yes.
Okay. Actually, I haven't did actually till now, so that's why I joined this session.
No. Watch the lectures for sure. You will get more
Yeah.
clarity on like what is happening. But these are the topics that is there. Yeah.
Sure, ma'am. Okay.
Okay.
Ma'am, in practice assignment, there is a question
Okay.
about 10 multiple select questions are given.
Okay.
And what is the problem? And for each question, there are 4 choices, and the student has to select at least one choice. And if the student selects all the correct choices, they will get 4 marks. The student, even if one option is not correct, then the student will get 0 marks. And what is the probability that he will or she will get at least a minimum of 16 marks?
Okay. Yeah, I think I found the question. It's in 7.1, right?
Yes.
Okay, I think I'll walk you through the solution. Oh, okay, or maybe
I could find a number of ways of choosing the 4 choices that I could find.
Okay.
One question, it is coming like 15 choices, 15 ways of choosing answer for one question. Out of the 15 ways, one way is the correct way, every other way is wrong. Like for one question, there are 4 choices, and the student minimum has to select at least one choice. So when I did the calculation, it is coming 15 ways of choosing a question.
Let's see. Let me see if I can solve it. Okay. So you have 10 multiple choice question.
Multiple select questions.
Okay, multiple 10 MSQs. Okay. In
And
each
question
question,
has 4 choices.
yeah, in each multiple select question, more than one option could be correct. In each multiple select question, 4 options are there. So let's say I have 1, 2, 3, so on till 9, 10. So for 1, I have 1, 2, 3, 4. Similarly, for everything, I have 4 options. 1, 2, 3, 4. Now, what we're saying is,
For one
if
question,
a student chooses all the correct options, then they should get 4 marks for that question. If everything is correct, I mean, if all the correct options are chosen, then they will get 4 marks, right? So all correct options for that 4 marks, if all correct options are chosen. Then we have, else he will not, I mean, they will not get any marks. Otherwise, we have 0. What is the probability that she will score at least 16 marks in the exam? X greater than equal to 16. Right? So 16 marks, when can the student get? Okay.
If they answer 4 right questions.
If they answer 4 right question.
Minimum 4.
Yeah, minimum 4. That's fine. Now, for each question, we have 4 options. So it is possible that you have 1 correct option in question, or 2 correct options, or you can have 3 correct options, or you can have also 4 correct options. So if you have 1 correct options, if you have only 1 correct option, then what happens? So, okay. It means if you have only 1 correct option, it means probability of the correct answer is 1/4. If you have 2 correct answers, but we should not look at correct answers, right? Okay. We cannot, okay. You have not been taught that thing, so that we cannot do. Okay. So 1 correct means okay. You can select in 4 ways. Fine. If you have 2 correct, you said you understood till 15 ways, right? That is what you said. You understood till the point where it is saying that any option could be selected in 15 ways, right?
Ma'am, if we select 2 correct option, then why 6 ways?
No, I mean, see, let's say I'm just talking about 1 question, okay? I have 1 question. Now, for this question, I can have 1 correct option, or 2 correct option or 3 correct option or 4 correct options. Okay. Let's say if I have 1 correct option, then this option can be selected in 4 ways. Fine. This is fine. Now, if we are saying we have 2 correct options, then you have to choose you have to choose 2 options from 4 options. That is nothing but 4 times 3 by 2, which is 6. Now, if we have 3 correct options for a question, you can choose the correct answer. You can choose the answer in 4C3 ways, which is just 4. And if you have 4 correct all the 4 correct options, then you can choose in 1 way. So, number of ways in which you can select the option, you can choose the option is 4 plus 6 plus 4 plus 1. That is 15 ways. Because see, you don't know like which, for a particular question, which answer, which answer is right, or even like forget which answer. You don't even know whether it is single correct or you have 2 options correct, or you have 3 options correct, or you have 4 options correct. So if you look at all the possibility, let's say I am a student and I am I have been given a question where the question is MSQ, and I need to work on, I need to mark the right answer for this. So I can look at, I will have to I can select the answer in 15 different ways, right? If let's say if I'm saying let's say if only 1 option was correct, then I had 4 ways. If I had, if there were 2 options correct, then I had 6 ways to select. If it was 3 options correct, then I had 4 ways to mark the option. And if there are 4 options correct, then I have only 1 way to mark the option. So we have a total of 15 ways to mark the answer for this question. Okay. So okay, now we have to find the probability that x greater than equal to 16. What did I define x as? I defined x as score to be 16. Score to be 16.
At least it's 15 now.
Score to be at least 16. Yeah. This is score I'm talking about. Okay. And this will come only if student marks. This will happen if student marks like at least 4 questions correct. Okay. Okay.
Yeah, ma'am.
Let me.
But there could also be a possibility ki, the student have answered 8 question, and in like in 8 question you have got half marks.
But
Like in
that
the
is
8
not
questions you have got 2 marks.
that is not given in the questions. The question says only if you mark all the options correct, you are getting 4. Otherwise, you're getting 0. That's all. There is no partial marking. So if
Okay.
I'm saying score is at least 16, it means and this will happen only if student marks at least 4 questions, right? Okay. So if we have 4 questions, so for 4 questions we'll have 16 options. I think that doesn't make sense. Okay. So for each question you have so for question number 1 to be correct, you have 15 ways. To mark the answer for question number 1, you have 15 ways. For 2, you have 15 ways. For 3, you have 15 ways. So on till question number 10, you have 15 ways. Okay. So for everything, you have 15 ways. Mm. You have to find x greater than equal to 16. So we should look at what? We should look at number of ways in which um, student get 4 or more questions. Correct. This is what we want. Number of ways. How many ways this can be done? Divided by the total number of ways of marking the question. That is fine. That should be. So you have 15 for everything. You have 15. So 15 times, do it 10 times. Okay. So this is what we have to find basically. If we can find this, then we are done. Okay. What is the probability that student get one question correct?
15.
Hmm?
No, 1
So
by 10.
one question correct means first of all, the student should choose one question out of 10.
1 by 10.
1. No, it won't be 1.
I'm 1 by 10. 1 by 10.
1 by 10. Can someone put the question in the chat also? I think.
Okay.
Yeah. we have to find probability that you have 4 question correct plus 5 question correct plus so on till 10 question correct, right? Okay, so we can also write this as 1 minus probability dot x equals 0. No, sorry, x I have taken as score. So just write it as probability that you have 0 question correct plus probability that 1 question correct plus probability that 2 question correct plus probability that 3 question correct. Fine. Yeah. This is okay. So I think instead of finding all this, if we can find this, then we are good. So probability that 0 questions are correct. Let's say some student is not able to answer even not marked even a single question correct. So that will be done in how many ways? So you have to choose 0 question, right? 10 choose 0, p to the power 0. So q to the power n is 0. And okay. What's the probability of correctness? Is 1 by 15. Okay. By 15 to the power 0. It's 14 by 15 to the power 10. I think this should work. Okay. All right, 1 question correct. That would be I select 1, and probability of question to be correct is 1 by 15. And correct is this. So this is 9. Okay. Then 2 questions correct is 10 choose 2. 1 by 15. Let me see if this works. I think this is fine. And similarly, 3 questions would be 10 choose 3 by 15 to the power 3, 14 by 15 to the power 7. Okay. So this is 1 minus 10 choose 0 is 1. This is 1. So 14 by 15 to the power 10 plus 10 times 14 to the power 9 by 15 to the power 10 plus 10 choose 2, 14 to the power 8 by 15 choose 10 plus 10 choose 3, 14 to the power 7 by 15 to the power 10. Can someone calculate this? I think this is going to be very lengthy. I will also do the calculation. So what is take this as common. So 14 to the power 10 plus 15 to the power 9 Is someone else doing the calculation? No, nobody is doing it. Mm. 1 minus 0.99700. Are you getting something 0.003? Something? Can someone confirm what is the answer?
Which one, ma'am?
Is the answer coming as something 0.003 or something?
Subtraction you're talking, ma'am? No, right?
Yeah.
It has to be
No, the final
0.003.
the final
Oh,
answer I'm
Oh,
talking
the
about.
final answer one.
Something, I mean, something, I mean, 0.003. I mean, this is the final answer that I got.
Yes, ma'am, it is
This is the
uh,
answer?
it says like 0.002, the range between 0.002 and 0.004.
Yeah, this is fine then. Okay, this has come out right. So are you able to figure out like what we did here? Are you able to understand what we did here? Yes, no.
Will be using binomial distribution in this?
Yeah, I have used binomial distribution, but it's a probability only.
Like it is looking like NPQ where P is passed, Q is failed, then P power 1, Q power 9, P power 2, power 8.
Yes, that is exactly what I've done here. I think if you have not studied, I don't think, but you will study in week 8 or 9 of binomial distribution. So maybe it will make more sense there.
In statistics, ma'am, you're telling?
Yeah, the stats one. Yeah. So what we did is, see, we had to look at I mean, even if you don't know what is binomial distribution, it's okay, but you can still understand. So we had to look at, we had to find what is the probability that score is at least 16, right? So score is at least 16 means the student should mark at least 4 question correct,
Yes,
right?
yes, ma'am.
So what we at least 4 question correct means either it can be either it is 4 or 5 or 6, or it can go till 10. So you
Yes,
have
ma'am.
to find probability that 1 question is correct plus probability that 4 question is correct plus probability that 5 question is correct plus probability that 6 question is correct, and so on. Instead of that, what we did is we did 1 minus 4 plus 5 plus 6, so on till 10. Okay, so that is the same thing, because probability of a probability of an event is like what do you call it? Here the event was 4, 5, 6 till 10, right? And if we do 1 minus its complement, that will give you that. So this is what we tried here. And find when we are doing using this complement thing, we have only 4 probabilities to calculate. Here we had some 7 probabilities to calculate. So this is much easier to say. Now, probability that 0 questions are correct, it means that all the questions are wrong. I mean, all a student has marked all the questions wrong. So that can be selected in 10. I mean, 0 questions correct means 10 choose 0. And what is the probability of a question to be correct? It is 1 by 15, right? Because any question, for any question, I have 15 ways to answer, right? Now, if for any question, if we have 15 ways to answer, so probability ki student has marked all the questions wrong. I mean, all the questions are wrong. It means probability that all the question has been marked wrong is 1 by 15 to the power 0. Basically, if probability of a correct answer is 1 by 15, probability of the question being incorrect is 14 by 15.
Yes, ma'am.
So it means all the questions are wrong. So 14 by 15 times 14 by 15, you go until 10 times. So we have written 14 by 15 to the power 10.
Okay, ma'am.
One question.
Could you repeat again this 14 to by 15 again, please?
See, 0 questions correct. It means all questions are incorrect,
Yes, ma'am.
right? So all questions incorrect, it means this two and probability of a question to be correct is 1 by 15.
Yes, ma'am.
So probability of a question to be incorrect is 1 minus 1 by 15,
Yes, ma'am.
which is 14 by 15.
Yeah.
Right? So if you have these 10 questions, right? And this is also incorrect. This is also incorrect. So this is also incorrect. Everything is incorrect, right? So this is just for each of the question. So for the question 1 to be wrong, the probability is 14 by 15. For question 2 to be wrong, it is 14 by 15. So we have 10 such questions, right? So 14 by 15 to the power 10. Okay.
Ma'am, we are calculating for 0 options to be correct. So in that
Mhm.
case, we choose that we are choosing the number of correct options that is 0, 10 choose, 10 choose 0. Then each making each
No, forget 0. I mean, 0 question correct means what? All the questions are incorrect.
yeah.
So probability of a question to be incorrect is 14 by 15,
Hmm.
right? And you have all the 10 questions incorrect. So 14 by 15 to the power 10.
What, ma'am, I am having a doubt here. Like, we are at one place we are looking 1 by 15. That is the probability of
You can.
question being correct multiplied by the like probability of question being wrong. That is 14 by 15.
No, maybe you can just forget this. I mean, this is fine.
Okay.
Don't think about it. I mean, anyway, it's just 0, right? So it's okay. So
In
this
this
is,
case it's 0, but in the next case it's not now. Then
yeah. So 14 by 15 to the power 10, right? Now, if I'm saying one question correct, so first of all, you should select which question out of 10 questions. So 10 choose one,
yes, ma'am.
right? Now 10 choose one. So either it can be question one, either question one can be correct, or 2 can be correct, or 3 can be correct. We don't know. That's why we are doing 10 choose one. Now, for any question, I mean, if you have to do one question to be correct, so let's say question one is the student marked correct and everything else is incorrect. Okay. All this is incorrect and only one is correct. So for the question one to be correct, it is the probability would be 1 by 15.
Yes, ma'am.
And for question 2 to 10 would be incorrect is 14 by 15 to the power 9.
Yes, ma'am.
And this we have done only when we are assuming that option or question number 1 is correct. But this can happen in 10 different ways. I mean, you can have either question 2 to be correct and rest everything is incorrect. You can have question 3 to be correct and everything else is incorrect. So that is why we are doing 10 choose 1.
Yep, got
Right?
it.
That is this. Similarly, 2 questions correct. It means you choose 2 questions out of 10 questions. And then probability of these 2 questions to be correct is 1 by 15 square. And the another 8 to be incorrect is 14 by 15 to the power 8. Right? Then 3 questions to be incorrect. Similarly, 10 choose 3, 1 by 15 to the power 3, 14 by 15 to the power 7. Right? Now, if I add everything and I subtract it by 1, I should get my answer. Okay.
Got it.
Okay. I think we'll close now. It's already 10:11. I think there will be 2 more sessions for week 7. So we can discuss further doubts later. Okay. So we'll close for today now.
Ma'am,
Yes.
I'm having some problem in the videos that is given in the website is not working for me for some reason.
Videos are not working.
Yeah,
I don't know. Did you try opening it in YouTube?
yeah, I tried it. It's not working there as well.
Okay, did you write this to support team or did you write it on Discourse, discussion forum or Discourse?
No, at first I thought that the videos might have been privated, but it's not even working for the previous weeks.
Okay, I think it would be good if you post that on Discourse. Then we'll have a look into it. Someone will take care of this issue.
Okay.
Yeah. Okay. All right then. We'll meet again in further weeks. All right. Good night, everyone. Bye.